Okay, second topic then is going to be bearings, and I just want to remind you of a quick few things about bearings before you have a go at some of the questions. So, bearings are always measured from north. Okay, so if you have a point, maybe point A, and it says measure the bearing of B from A, the first thing you have to do is draw in your north line. Okay, so bearings are always measured from north. They are always measured in a clockwise direction. So even if the B was over here, and it kind of makes more sense to you to go to the left, that's not right. You've always got to measure round in a clockwise direction. And the last thing to remember is that bearings are measured as 3 figures. So when I measure that bearing of B from A, it comes out as 92 degrees. I'd write that as 092 degrees in my answer. Okay. Just a tip from when you're measuring them, the first thing I'd always do is join the 2 points together. So if you wanted to do B from A, join that together first with some sort of line, just so it's really clear what part you're measuring. My very last tip is your protractor goes on wherever you're measuring from. So on this one I said B from A, so A is where I put my protractor. Okay, you might want to make a note of that. So wherever it's from is where you put your protractor. Okay, what I'd like you to do now is have a go at some of these questions, and then the video is going to show you how to answer them. So pause the video now, please. Okay, and these are the questions that you should have been working on, hopefully. So the first one then, work out the bearing of B from A. So there's going to be where I would put my protractor if I did need it, but this diagram is not to scale. So I think I'm going to measure all the way around clockwise from north, and I need to know how big that is. Well, I know something. I know to get to the straight line it's going to be 180 degrees, and then they've told me that that little extra bit is 40 degrees. So I need to add that on, 180 and 40, which gives me a bearing of 220. Question 2. Write down the bearing of A from P. So from P, that's where I'm starting. So I need to measure clockwise from the north line, and they've already told me that that's 60 degrees. I just need to be careful that I'm writing it as 3 figures. Last one, work out the bearing of B from P. So I'm still going from this north line at P, and I want to go clockwise all the way around here. Well, I know a little bit of it already. This little section in here is 60 degrees. I just need to know how big this is. And I can work out that remaining part because I know that angles around a point add up to 360. So I can do 360, take away what I've got so far, which gives me that remaining part as 160 degrees. So I've got 60 plus 160 degrees, which is 220 degrees again. Okay, up to question 3. Now these diagrams are to scale, which means you can measure them with your ruler and potentially your protractor. So first one, measure and write down the bearing of B from A. Remember the from bit is where I put my protractor, so I'm going to pop it on there, line up my 0 line. I think to myself, this is not ideal because B is around the other side. But think about what you know. If I put a little line in here, I know that all the way around to here is 180 degrees already. So what I can actually do is put my protractor on the other side and measure what I have to get left to get to B. I want to measure this bit in here to see how far I need to keep going. So if I line that up nicely, that gives me, I think that's about 150 degrees there. So to get to B, I need to go 180, then 150, which is 330 degrees. And the last part then on the diagram, draw a line on a bearing of 107 from A. So I'm still going from A, and I need to measure around to 107 degrees, which is about over here. If I put a little mark, I can then draw my line. Doesn't matter how long, it doesn't say anything about it, coming off at 107 degrees. Annoyingly, goes right through my answer. Okay, question 4. So for this question we've got 2 ports. First question, measure the bearing of Q from P. So it's the from bit that I want to put my protractor on. I line up my 0 with my north line. And I've got the worst protractor in the world there, but that looks to me to be roughly, I'm going to go 50 degrees. It's probably 49 to be more accurate. So 50 degrees, I'm going to write it as 3 figures though because it's a bearing. Okay, we've got something else to draw on then. Rock R is on a bearing of 150 degrees from Q. So this time we're putting our protractor lined up on Q. First bit of information is that it's 150 degrees, so I'll put a little dash where 150 degrees is. But this time, unlike that last question, my line does need to be a certain length. It says on the map it's 6 centimetres from Q. So I need to go in the direction of that point I've just put in. I'll get my shark ruler. But it also needs to be 6 centimetres long. So making sure it goes through my point, it's 6 centimetres long. There we go. Which means that is where R ends up. On to the other side then. So we've got question 6 next. Got 2 villages here. This one, it is a scale drawing, and I notice there's also a scale that I need to take into account. So the first question says, what's the real distance between them? Well, the distance between them is this line here. So you need to measure the line, you need to measure it really accurately. Depends on your printing, but mine looks like that's about 6.4 centimetres. Okay, but that's just the distance of the scale drawing. Here, I've got 4 centimetres represents 1 kilometre. So if I want to get from centimetres to kilometres, I need to divide that by 4. I think I'll use my calculator. That gives me about 1.6 kilometres. You might have something slightly different, all depends on how yours is printed. Now I've got a new point to draw on. A is on a bearing of 38 degrees from Beckhampton. So Beckhampton, the B is where I'm going to put my protractor. And I need to be on a bearing of 38 degrees. So that's about there. Obviously good practice with this would be to use a pencil. I'm using a pen so you can see it. So that's my little mark, 38 degrees from B. And it says on the diagram, A is 6 centimetres from B. So I don't need to worry about any of the conversions because it's told me about what it is on the diagram. So I'm just going to measure 6 centimetres in the direction of that point that I've put on to my diagram. And then that gives you A located up there. Last one then, we've got 2 telephone masts. First one, measure the bearing of B from A. Remember the from bit is where you put your protractor. Not quite sure how many times I've said that now, apologies. If I measure it up then, again, worst protractor in the world, but I think that's about 59-ish degrees. So I'm going to go 0.59 when it comes to my bearing. Last one, Mast C is on a bearing of 160 degrees from B. So that means from B, protractor, I need to do 160 degrees, which is about there. And then it says on the map it's 4 centimetres. So I need to go in that direction. Only 4 centimetres this time. Just going to take me to there. And that is where C is located. Okay, hopefully then you've done well at revising bearings and revising sectors and arcs today. Best of luck for that exam, which is next lesson. I won't be there with you, but someone will set it up nicely for you. Make sure you've got all your equipment. I know that worst comes to worst, I'll lend it to you, but there's nothing more stressful than turning up and realising you don't have a calculator and you've got to ask for one. So make sure you're sorted with that. See you all soon.